imagine the scenario you ran Terraform pipeline using GitHub Action. Everything looks perfect, but in the next run, something strange happens. Resource gets duplicated, infrastructure changes unexpectedly, and even worse, some resource gets deleted. And the worst part, you didn't change anything in the code. So what went wrong? The answer is one of the most important concept that is infrastructure as a code, and the file is Terraform State. So in this video, we'll deeply understand Terraform State, not just theory, but how it actually works in real GitHub CI/CD pipeline. So first, understand what is Terraform State. So let's start simple. Terraform State is a mapping file. So it connects two things. So your Terraform code, the desired state, what we call, and next is real cloud infrastructure, the actual state. So in simple term, Terraform State is memory of your infrastructure. So it remembers what resources were created, what are their current configuration, and how everything is connected. So without state, Terraform becomes blind. It cannot track existing resources and update safely, and even cannot manage infrastructure properly. So why GitHub Action changes everything? So let's introduce CI/CD. So we are not running Terraform on local machine. We might be running it on GitHub Action or some Jenkins pipeline, right? So if we talk about GitHub Actions, so this changes everything. Why? Because GitHub Actions or even Jenkins are the runners, so they are not hosted locally. So they are temporary, stateless, destroyed after execution, and they don't remember anything if it is not written outside that Jenkins file or Jenkins runner or the GitHub Action runner. So that means there's no local Terraform state file. So the question becomes, where does Terraform store state file in case of CI/CD? So the answer is remote state backend. So it could be anything. Like if you talk about GCP, so it could be Google Cloud Storage. If it is AWS, then it is S3 bucket, and if it is Azure, then it is obviously Azure Blob Storage. So what are the benefits? Why we are storing in Terraform remote instead of local, right? So there it has its own advantage. So first thing is shared access. So multiple engineers, if I want to contribute and my colleague want to contribute, then in that case multiple engineers and pipelines can use the same state. So if the second point is consistency. Everyone works in a single source of truth. And third is reliability. State persists even if the runner are destroyed. So and last thing is supports locking mechanism. That means if I am running something and my colleague is running something, so it's not like uh, both can both can do the changes in state file. So that is these are the biggest benefit of remote backend, remote state file. Now let's talk about state locking. So now imagine the scenario. Pipeline A is running the Terraform apply, and then at the same time pipeline B also runs apply. So before that, let's jump into right away what a Terraform state file looks like. So I have a sample over here. So it could look like something like this. So I'm not going to deep into this, but yeah, it is overall. We can see the type of resources. For example, you have this Google project service, and it says compute API, and if you go even down, we can see Google SQL database instances. So based on the resource, whether it is VM, whether it is ELB, whether it is what we call VPC, network, subnetwork. So we have each and every details over here in Terraform state file. So whatever we are writing or deploying via Terraform, so it is going to be there in this state file itself. Now coming back to the state locking. So imagine this scenario. We have a pipeline A that is running Terraform apply, and at the same time pipeline B also starts apply. So without protection, they both try to modify the same infrastructure, right? So this can cause corruption, inconsistent state, broken infrastructure. So that's why Terraform uses state locking. So broken infrastructure means, so I'm trying to create a VM that has just one disk, and someone else is trying to create another VM that has two disks, and some third person trying to say change the configuration of the VM. Say the first VM want to change the disk to 1 to 10, and the second VM, which was the second person was doing, want to change to 3 to 1. So in these cases, so it is going to be inconsistent, broken infrastructure, and even sometimes go for the corruption. So in that case, Terraform uses state locking. So that simply means only one person or one process can modify state at same time. So other person must wait to let the first one complete, and then only lock is released so that they can start working on their operations. So next, so let's take example of CI/CD workflow. So what happens? We push. Let me open an example so that I can show you. YT, I cannot recall. Let's see. So this is the sample workflow, and let me open this workflow file. So this is sample work. What it is doing, it is simply this deploying some infrastructure like set of VMs. Overall, it is 3-tier. Not complete right now, but yeah, it is deploying some VM and a database SQL, a cloud SQL database. So this is simple workflow. And let's go back to this CI/CD workflow architecture. We run the workflow GitHub push. It starts the runner like we talked earlier, and it is going to Terraform init, initialize it, remote state backend. So it is for our use case it is GCS, and then Terraform, then plan, then Terraform apply, and state update in the backend. So when multiple pipelines try to modify infrastructure simultaneously, Terraform uses state locking so that only one process can apply change at one time. So now next question is why remote state is critical. So without remote state, infrastructure duplication can occur, like we spoke earlier, and we have resource may be lost or overwritten and it became unsafe. So no single source of truth exists, right? So that's why remote state is very important, so that we can work together. I mean, all of our colleagues and engineers can work together. So yeah, now let's take example. So this is the same file, I guess. Yeah, so this is a shorter version of the same file. So let's talk about how we configure backend. I mean, how we configure remote state file. So if we talk about GCS, means Google Cloud, so we have this option in Terraform where we can define GCS. So we have this backend GCS, and we have to provide the bucket name and the prefix. So prefix is like a folder, like so we have this file, your Terraform. It could be bucket name, and if we mention prefix, so prod slash state. So that this means there's going to be two folders, the prod folder, and inside prod folder there is going to be state folder, and inside the state folder it is going to be default.tfstate. So let me open this. All right, so I have a bucket. So I have this mentioned this state file. So let me go back to the VM instance. So let me go back to the code right now, and we'll see how we have configured. So I'll go to the Terraform and then go to backend. So we have to if we want to define backend, then we have to go like this. So I have defined backend GCS over here, and then I'm calling it in the code itself, in the deployment.yaml file itself. So if I go to 1 second. So if I go to Terraform and then go to, if I go to GitHub workflow, and over here in Terraform init, I have defined the backend config, the bucket. So the bucket is named like this. So what we can see it over here, the same format, the project ID, then tfstate. This is just for an example. And inside we have DevOps project. So this is the prefix I have mentioned, and then the default. The name of the tfstate file is default.tfstate. It is it can be seen over here. So yeah, this is pretty much of it. Now let's go back to our page again. So let's be very clear. State is not just a file. It is the core intelligence of Terraform. It stores resource ID, dependencies, metadata, and sometimes even sensitive data. So that's why state security is extremely important. And if state is lost or corrupt, infrastructure can break, resource can be orphaned, and recovery becomes very difficult. So that doesn't mean we cannot recover it, but we are with the option to do Terraform import. But again, this is going to be very challenging if our infrastructure are pretty complex. So finally, we can conclude that without Terraform State, our infra as code is pretty blind. Now, question for you. So let's take example like I have a VM, and the instance type of that VM is say enter standard 2, and someone goes to the VM console and changed the instance type to enter standard 2. So what impact is going to be on while we run TF Terraform apply? How it is going to react? So let me know in comments. So this was all about Terraform state, local state as well as remote state. And in the next video, we'll be going even deeper, like understanding state drift, Terraform refresh, state file content, sensitive data that could be at risk in the state, and even backend initialization concept, workspace concept, and state dependency graph, state corruption scenario. So that is going to be even deeper. So see you in the next video. Stay tuned. Bye bye.